Hello and welcome back again. Today I have this awesome display I got off of eBay. It was really cheap. What this is a 12 line by 40 character plasma neon dot matrix display. It's kind of like one of those little LCD displays but on steroids. There's also a touch screen built in. So we'll go around it here. You can see there's no less than 5 circuit boards stacked up here. 1, 2, 3, 4, and then 5. So we got a button, or the infrared touch board is here. The display sits on this board. This is like a high voltage driver, and this is a whole bunch of TTL stuff drivers, and then this is like the control board up here on the top. So we got an 8048. This is a ceramic prototype 8048, no less. I bought 2 of these displays. This one appears to be used, the other one's new. And during the teardown phase, I'll show that this is a different CPU, but pretty sure this is a prototype CPU. The package appears blank and there's no writing on it. And then, let's see, we got some dip switches for baud rate. There's a serial port over here. I got this resistor on here for testing. And then this is some kind of parallel port. They say how to use it in the manual, but I'm not going to use it. Power goes in up here. It takes 5 volts at 2 amps and 125 volts at about 160 milliamps or so the documentation says. And then here's the few parts under there. And these cables here, there's 6 of them. These connect to that touch panel. And here's the other side. Lots and lots of 0.1 inch headers all the way around it. Nothing but 0.1 inch headers. So that's that. I think first I'll fire this bad boy up and we'll play with it, and then I will do the teardown. I already tore down the other display, so I'll just show off the pieces and then put it back together, and I'll test it too. So that's that. So to get this to work, I made this power supply here. This isn't finished. I have the transformer I wound. This is a custom wound transformer. There's 8 primary turns, 122 secondary turns. I calculated. That's an ETD29 core. Got that off of eBay. Then it's just some perf board, and I was testing out some various things. And there's a neon that lights up. Power goes in this connector and comes out. And it's just a TL494 and then a FET driver and a big FET. Big 400 volt capacitor there at 47 UF. That came out of a UPS actually, and I got some bleeder resistors, so this seems to work, so we'll hook it up. There, okay, we're all hooked up to Mr. Power Supply there. Turn it on. I think I'm going to unplug this first. This is the high voltage power supply. Fire it up here. Okay, it's drawing about 2 amps at 5 volts there. And then, here, turn it off. Plug the high voltage back in. Like that. And then watch the high voltage come up. Oops. There we go. And it appears to be working. There's nothing on the display yet, but that's because I gotta touch it. Oh, yep, it's working. So basically what's happening over on the left side over here, there is that resistor I put across the serial cable, the in and out of the serial here. So whenever you touch on the display, it relays that back to the screen, and basically it's saying the coordinates. So if I press up in the upper corner here, it's 1, 2. Press over there, it's 1, 1. And over here it's 120, 120, 119, 118, 716, and so on. And I go down, and so now it's saying 12. Row 12, row 11, row 10, 9, 8, 7, 6, row 3, row 2, row 1. So the maximum coordinate is 1220, and the minimum is obviously 1, 1. So it appears to actually be functioning. I did notice one of the columns is kind of flaky. Let's see, I'll give it a little technical tap with the screwdriver here. Seems okay. Looks like it's drawn about 1.2 amps from the 12 volts, and we're getting about 2 amps on the 5 volts, so that's not too bad. So the whole panel's taking about 20 some watts to run it, and you'll see why it takes 2 amps at 5 volts here in a minute during the teardown. So that seems to be working. I'll hook it up to Putty and plug it into the computer and actually be able to write data to it. If you ever do anything that involves serial, I highly suggest making one of these. What this is a DB9, which just plugs into any DB9 serial port on your computer, but it has no less than 2 DB25s. And this is because on one of these the wires are crossed, because it's kind of like Russian roulette. You don't know if the serial port's going to be wired straight through or cross-connected. So by having both of these connectors, you don't have to guess. You just try it until it works. So I got it. It looks like it's working. So over here, whenever I type something on the display, it shows the coordinates there. And that looks like it's all working. And when I type over here, oops, so when I type here, it goes over on the display here. So now I can actually type a message. Oh, that's it. Oh, I have the parity wrong. Here, I gotta set the parity properly. Ah, there we go. So basically, this display is 9600 baud, 7 data bits, and then odd or even parity actually. So it's even parity, 7 data bits, 1 stop bit, 1 start bit. And of course you can't back up. Yep, seems to work. And then according to the documentation here, so I got Mr. Documentation, it says, oh, here we go. I can turn the cursor on by sending 16 character 20, which would be Alt 20. Oh yeah, there's the cursor. Okay. And then I can clear the display by sending 12, it looks like. Or, sorry, Alt 12. Oh yeah, that worked. And I can make it FEEP by sending it the bell command. Yeah, that seems to work. So let's see, I will copy some text in there. So I just copied some information about the PPU. Oh yeah. That looks like it works quite well. Whoops, I just bumped it. Ah, that's pretty cool. Oops. Oh, clear the screen. Whoop, write the data. How about that? Let's try a little more text here. That's interesting. When you write past the end of memory, it just sort of goes off at the end there and it doesn't wrap back around. I wonder if you do enough if it'll wrap back around. Oh yeah, looks like it does. That's interesting. Yeah, there's 480 character cells on the display and the memory must be 512 characters deep, so it runs off the end and then comes back around, so a bunch of the characters at the end there you can't see. The last, what, 32 or whatever. Cool. Whoops, it's left alt. So it looks like it works. I'm wondering if I can change this character set easily. I think I can. Like they say on the cooking show, here's one I prepared earlier. So this is the infrared button board. There's nothing on here except some emitters and detectors here, and the little, this one has headers, the other ones are soldered on the other display. This is the second display that was never used. So there's all these emitters. There's 20 pairs here and 12 pairs here, for a total of 240 different sectors you can press on the display itself. And here's the actual front itself. And the way this works is there's actually prisms here. See, there's actually prisms along each edge here. And then the infrared emitters, it sits upside down like this, and they just fire their infrared up, straight up, and then these prisms reflect it across and back out for both directions. And then of course the next thing is the display glass itself here. And this is brand new glass. The other one, like I said, is used, but it looks pretty good. But on the back, there's the evacuation port where they suck the vacuum out, put the neon in. Then just lots and lots of resistors here. These resistors are pulling up each of these cathodes here to 125 volts. And the way this works is there's on this display here, what they do, they actually scan it left to right. And there's 200 columns of pixels. So they only turn one column on at a time and just step across the display like this, lighting up the proper rows to show the characters as it goes. And then plugged into the display board is what I call the high voltage board. There is a lot of transistors on here. There's no less than 200 transistors here. There's some here and some here. There's 200 here, and these drive all those individual columns. And then all these circuits drive the rows, and what they've got on each row, they've got a transistor, a resistor, a capacitor, and a diode. And what this does, this acts as a charge pump. So when they turn this transistor on, it takes that 125 volts and doubles it to about 250 and really socks that glass with the 250 volts then. And also these capacitors block DC, so if the scan going this way is ever stopped, the display won't get damaged from overcurrent on one column because these capacitors block the DC. So if these aren't being turned on and off, nothing can light up. So that's like a safety feature. And then next is the main control board here, and what this does, this is what actually runs the display, and there's yet more of those drivers here. So there's a total of 96 circuits of this driver to run all 12 rows, because there's 8 pixels per row, so 8 times 12 is 96. And then here's the little 2732 style ROM that contains a character set, so I will probably program my own and plug it in that socket. And all this stuff is just counters and shift registers and stuff. It's all TTL logic. And a lot of this TTL logic is why the display draws 2 amps at 5 volts. This is all 7.4 LS series parts, so not exactly the most power thrifty of things. And finally, we got the control board. And this control board here is different than the other one slightly. The layout's different. This has that plastic 8048 in it, and the other one's got the ceramic one, but the circuit appears identical. It's got that beeper, and these transistors are driving like the rows for the touch display, or the touch screen, and then there's your serial port, that little parallel port doodad, and then this connects to the display board there. So you could theoretically run it without this board because this interface is documented. You can actually, on one version of this, it doesn't come with that jumper, and you just interface the display yourself directly, and then this top board just does nothing but the touch part. And then these are the connectors here that go to the emitter detector pairs. And that's pretty much it. There's a UART on here, a 6850, that 8048 like I said. And then the dip switches set the baud rate and a few other minor things, so that's pretty simple. And it's all documented in that manual I have, so getting this thing to work actually is not very difficult. You just apply 5 volts, 125 volts, and it works. So I hope you found that informative, and if you like it, let me know, and I may post other displays and weird things like this that I have. Thanks for watching.